Alright, let's do this as a take two, because apparently I went through this whole set of notes and apparently it decided that there was going to be something wrong with the recording. Happy joy, I love that. That's sarcasm, by the way. Anyways, so we're going to look at rational exponents, which is actually chapter 7, section 3. I will be able to, and what I want you to be able to do here is to define rational exponents and utilize properties of equality to solve simple equations. I'm stating this in terms of I, as in you should be able to say, I will be able to define rational exponents. Okay, so what is a rational exponent? A rational exponent is basically, oh, that's too far. Basically, a rational exponent is this. If I say something is in a fractional exponent, now so rational means fractions, that the denominator becomes the root and the numerator becomes like the power that the number is raised to. So you're going to you can't just think of square root symbols, but this is similar to that. But you can have extra roots, like it doesn't have to be just a square root. Also keep in mind that n is greater than 1. So for example, here's a very simple example. 25 to the 1/2 power. What that means is I am saying make the little root symbol, and we're saying put the 25 in there, and then technically you would be saying there's a 2 there and a 1 there. Now, that would be square root, but that's the most common one. So when I don't put a number there, that's considered to be a 2. Any other number that you may have there, like if I had a different number here, then you're supposed to put you have to put that number here. Okay? So, keep that in mind. Anyways, 25, the square root of 25 is 5. There you go, because that means 5 times 5 was equal to 25. So if I say something like 256 to the 1/4 power, then that means I'm going to put the root symbol. I'm going to put the 4 there. So I'm saying taking the 4th root, 256 to the 1st power, and then you can type that in the calculator and find the answer to be just 4. Okay, so again, the key concept here is where do those numbers go? And the reason why this answer ends up being 4 is because if I say 4 to the 4th power, I would get 256. In other words, this tells me how many times a certain number had to multiply itself to get that number that's inside the little root symbol. Okay? So, moving on. So again, 4th power of 81 is 3. You need to remember these type of things. Again, these are things you could easily type into a calculator. Okay, now how can I rewrite them? So just like I could go from fraction exponents to this, how can I go backwards over this way? So what we can do here is, what if I said square root of 18? How can I write that as in a rational exponent? Well, I could say 18 to the 1/2 power. Because remember, there's an exponent to the 18, and then there's a root number to the square root symbol, or to the root symbol. So if I wrote something like here, 8p, the square root, because remember, there's no number there, you presume there's a 2, a square root. So you would say 8p to the 1/2 power. Now, keep in mind what happens if you have something like this, 5x to the 1/2. The 1/2 is only with the x, not the 5. So the 5 is going to be on the outside, then you're going to put the root symbol, the x on the inside, and then you could say 2 and 1, or you can just leave it like that. Okay, so to kind of reiterate where I'm coming up with those numbers and how they stick. Okay, now notice this example, the 3rd root of 25, which means then I would write 25 to the 1/3 power. 64 squared. Notice, look at this one. I've got the 5 and the 2. So there's going to be my numbers that become part of my fraction. So you can see how these are very simple translation examples. Okay, so what does that lead us up to? Now we can also talk about the power property of equality. For any real number b greater than 0 and b is not equal to 1, b to the x power is equal to b to the y power if and only if x equals y. What does that all mean? It means basically now we can set up, say, exponent equations. And we can basically say if I have the same base, I can solve for x from 2 exponents. In other words, like here, You see these two examples, I'm saying 5 to the x power is equal to 5 to the third power. Therefore, x equals 3. 4 to the n power is equal to 4 to the 1/2 power. Therefore, n equals 1/2. What that allows me to do is something like this, very simply. If I said 3 to the x plus 2 power is equal to 3 to the 5th power, I could drop the base and say x plus 2 equals 5 and solve for x by subtracting 2 and getting x equals 3. Same idea here. Okay, here's the exact same problem that you just did, but written differently. This is how you're normally going to see them. So you need to be able to say, okay, well, 3 to the x plus 2 is equal to 243. Well, they're different. There's nothing I can do. Wrong. Take the smallest base, in this case 3, and see if you can convert that one to be that same base. Well, guess what? 3 to the 5th power is 243. So you can go back, say it like this, and then solve. Now, in Algebra 2, you actually learn how you can use other little things to solve this no matter what. But this, for now in Algebra 1, we will stick to, you can convert them to the same base. Should always be able to convert them to the same base. Now, my recommendation is, from your notes, make a powers chart. In other words, make a chart that lists, like, say, 2 to the 1st, all the way to 2 to the 10th. 3 to the 1st, 3 to the 10th. 4, 5, 6, 7, 8, and 9, put those raised to, like, say, at least, I would say, the 6th or 7th power. Every single one of them. So we're going to do that as an assignment probably tomorrow or Friday, but you need to work on that. And here's why. If you look at a problem like this, 2 to the x minus 3 power is equal to 512. Well, what is 512? If you go back to your chart, you could easily see 512 is 2 to the 9th. So then that means then I could say 512 is equal to 2 to the 9th. And then since the bases are now the same, I can say x minus 3 equals 9. So then solving for x tells me x is equal to 12. Okay, so that's basically what we've wanted to cover here. That's it. Hopefully you will understand this. We will try to go over this as much as possible. But I guess that's pretty much it. I hope to see these notes, and I'm sure that you will all make me happy and have those notes ready for me to see the next day. Thank you so much.